Hello dear students, welcome to Byjus Exam Prep. Now under this how to start algorithm series, I am starting asymptotic notations. Actually yesterday I started with this asymptotic notation part 1. There was some technical issue towards the end. Okay, so let me continue from where I stopped. I already completed big O notation. Okay, now we continue with the remaining notations, that is big omega, big theta, and if time permits, small o and small omega notations. Okay, dear friends, let me start with asymptotic notations part 2. See, if you understand this, even yesterday's class you can understand, sir. After completing this also you can review yesterday's class. Am I clear? So let me start with this asymptotic notations part 2. Of course, I already given my introduction. Myself Sridhar Sir, I am having 20 plus years of GATE experience. Okay, and my qualifications are M.Tech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. Okay, so towards the end, if time permits, we can discuss that more. So let us start with today's topic. Okay, so let me start with today's topic, my dear friends. The method for identifying whether Fn is big omega of Gn. How to check whether Fn, small fn, is big omega of Gn. That is, for Fn, Gn becomes asymptotic lower bound. When this happens? See, when you want to say Fn is big omega of Gn, what does it mean, sir? Fn is asymptotically larger than Gn. Fn is asymptotically larger than Gn. See, there is a difference between Fn is greater than or equal to Gn and Fn is asymptotically larger than Gn, my dear friends. It is normal greater than or equal to, but here we don't want this. Asymptotically larger than Gn. What does it mean? We can find, so if you want to see it as a method, find a constant C and another constant N0. How? Such that you have to find a constant C and another constant N0 such that C times Gn is less than or equal to Fn. So it's not like Gn less than or equal to Fn. See, obviously when Fn is greater than or equal to Gn means Gn is less than or equal to Fn. But here it is not Gn less than or equal to Fn. Constant times Gn should be less than or equal to Fn when for large values of N. When it should happen, sir? It should happen for, hi Jagdish, are you from Andhra? Yes, I am from Telangana. Okay, my mother tongue is Telugu, my dear friends. Okay, right. C times Gn is less than or equal to Fn when it should happen for large values of N. It should happen for large values of N. So we have to find one C and one N0 satisfying this condition. If you can able to find that one C and one N0 satisfying this condition, you can say that Fn is, actually we write equal to, strictly speaking we have to write belongs to. Fn is big omega of Gn. That is, Fn grows at least as fast as Gn. We say that Fn grows at least as fast as Gn, or Fn is having order of growth equal or greater than Gn, or we can say that Gn is asymptotic lower bound of Fn. Gn is asymptotic lower bound of Fn. So let us solve a problem to check how we can prove that a function is big omega of another function. So if you want to prove that f5n square is big omega of n square, what we need to prove, sir? We have to find a C and N0. How? Such that, see, this is the function, right? So some constant times of this function you take, this should be less than or equal to what? 5n square. And it should be true for all n greater than or equal to N0. So for a given C, we have to find N0. For a given C, we have to find N0. Anyone having doubt, please ask me, sir. Okay. So now what we do is we fix a c. Generally to prove this, because it is 5n square, now you can take any constant less than 5, any real constant, positive real constant less than 5, it works. Okay, because we like integers very much, so let us take some constant integer smaller than 5. What is it? Let us take c is equal to 4. Now, does it happen, sir? 4n square is less than or equal to 5n square? Does it happen always, or for some specific values of n, or after some particular value of n? When this will happen? So you can solve this. You can substitute n. Actually 4n square is less than or equal to 5n square for n greater than 0. It actually satisfies for all n greater than 0, because we need to prove it for positive real constant. Am I clear? So actually we can write like 5n square minus 4n square is greater than or equal to 0. That means n square greater than or equal to 0. Because we want positive real constant, we can take any n greater than 0, my dear friends. Okay, so what should be n naught now? What should be n naught? You can take any positive real constant, sir. You can take 0.1 also, it works. Anything greater than 0. So your n naught can be, because 0 we cannot take, no positive real constant we want. So you can take anything greater than 0, you can take it. Am I clear? So for this given c, what is the value of n naught, sir? You can take 0.1 or you can take 1 also. Because after this condition is satisfied. After this n value, this condition is satisfied. Actually here it is satisfied for all positive real values of n. Am I clear? Anyone having doubt, please do ask me, sir. Okay? So if you want, you can try that way, or you can do one thing like substituting the values of n. But for this problem, there is no need of substituting any value of n, sir. Directly you will get the answer. Let us take one more problem. Sorry. 2n cube minus 5n is big omega of n cube. You want to prove this. What do you mean by this? Again, same thing, sir. We have to prove some constant times of n cube is less than or equal to 2n cube minus 5n. So you have to find a c, and corresponding to c, you have to find a n naught. After that n naught, this condition must be satisfied. After that n naught, this condition must be satisfied. So let us take what value of c you want to take. Which value of c you want to take? Any suggestions, my dear friends? कोई डाउट है आपको? कौन सा वैल्यू ऑफ c हमें लेना चाहिए? कोई भी चलेगा? My dear friends, इधर constant 2 है ना, इससे smaller होना है तो you can take anything smaller than 2. Because as I told, we generally like integers, we take c is equal to 1. We take c is equal to 1. Substituting c is equal to 1, we get n cube less than or equal to 2n cube minus 5n. Now for what values of n this condition is satisfied? One method of solving it is you can put n is equal to 1, verify, n is equal to 2, verify, like that you can do it. That is general way what people do it. We also do mathematically, my dear friends. First let us do general way how people like to do it. They substitute n is equal to 1. If you put n is equal to 1, 1 less than or equal to 2 minus 5. 1 less than or equal to minus 3, correct? No. Wrong. So n is equal to 1, it is wrong. Now put n is equal to 2. So if you put n is equal to 2, what happens? 2 cube. 8 less than or equal to 8 to 16 minus 10. 8 less than or equal to 6 is also wrong. Can you tell me what is the value of n? Using this method, I want you to tell. Using this method, I want you to tell what is the value of n. How long it takes? How long it takes? कितने देर लगेगा? You can write the answer, sir. There is nothing wrong if it is wrong. Okay? You can write whatever answer you get it. Am I clear? So you can try that way. Otherwise, what we can do? Take this inequality n cube less than or equal to 2n cube minus 5n. Taking n cube to the other side, you get n cube minus 5n is greater than or equal to 0. Taking n common. Is it n? Okay, fine. No problem, we'll take that. Okay. Taking n common, we get n square minus 5 greater than or equal to 0. Because n should be positive, product must be positive means product must be positive means both must be positive or both must be negative. Obviously n is positive means this n square minus 5 must be greater than or equal to 0. Okay, so what, because we want greater than or equal to 0 and n should be positive, that is the idea. So what we do, n square is greater than or equal to 5, so what is the value of n, my dear friends? N should be greater than root 5. N should be greater than root 5. Am I clear? Hope you understand. So which value of n you take it? So obviously 2 point something, that value you can take it, my dear friend, but if you don't like real values, you can try some integer values, something like 3 you can take. For example, if you substitute n is equal to 3, what happens? 3 cube means 27. 27 twos 54 minus 15. 54 minus 15 means 9, 39. 27 is less than or equal to 39 is satisfied. So actually you can take n naught is equal to 3. That is, this particular condition, Cn cube is less than or equal to 2n cube minus 5n is satisfied for all n greater than or equal to 3 you can write. Actually it is root 5. You can write root 5 also, there is nothing wrong. You can write root 5 plus 0.1 also you can write. But as I told you, we generally like integer value. We generally like to represent it as some integer value. That's it. Yes, Suparna Das, very good. N is equal to 5 nahi, n is equal to, n square is equal to 5 hai. So n value root 5 hoga. Root 5. N naught is root 5 hoga. So you want integer value, you can take 3 or you can take root 5 if you want exact answer. Hope Suparna Das, is that clear? समझ में आया है? See, there is nothing wrong if you do mistake, my dear friends. We can correct it and we can continue. What is there in that? Okay? If you do mistake, then only we can learn faster, right? समझ में आया है? Hope you understand. So this is the idea, my dear friends. Or as I told you, you can substitute n is equal to 1, that is general method what people follow. But whenever you can mathematically solve the inequality, from that also you can find the values of n, my dear friends. Am I clear? If you are having any doubts, please ask me. Now the definition. So you understand what is big omega notation? Okay? We say that Fn is belonging to big omega of Gn. What is the meaning of that? We can find positive constant C and n naught such that C times Gn is less than or equal to Fn for all n greater than or equal to n naught. So let us try to understand visually. Okay? Let us try to understand this visually. Now look here, this is Fn. And this is your C times Gn. Now let me give you some points quickly. This is point A, and this is point B, and this is n naught. Now please tell me at A, which function is larger? Fn or C times Gn? At point A, which function is larger? Good evening, sir, and good evening all students. Hi, good evening Anil Prasad sir. Very good evening. Yeah, for at A, which function is larger? Fn or C times Gn? Fn or C times Gn? Which one is larger at point A? At point A, which function is larger? कौन सा लार्ज है? Fn लार्ज है या C times Gn लार्ज है? Fn is the green graph, C times Gn is the orange graph. Which one is larger? Okay, very good. I only answer. So obviously Fn is larger, and at B if you see C times Gn is larger, but if you see this n naught, at n naught they are equal, but after n naught if you observe, always Fn dominates. Always Fn dominates. Wonderful, wonderful Vaishali Srivastava. Wonderful, perfect. At A, Gn, not Gn, at A Fn dominates. Okay, maybe you are giving answer for B, maybe. I haven't seen that, sorry for that. There is a slight delay, my dear friends, so I have to wait for your answer. So if you can quickly answer, I will be generally waiting for around 20-30 seconds, because in YouTube that delay will be there. Am I clear? So if you are answering regularly, I will be waiting for your answers. Otherwise, I assume that you are expecting me to answer, then I answer. Got it? Right. So what is happening, sir? After n naught, after N naught, this Fn dominates C times Gn. That is, this condition is satisfied. That is for large values of N naught. What is this N naught, sir? You can call it as the starting point for your large values of N naught. You can call it as the starting point. That is, after N naught, any N is larger for us. After N naught, any N is larger for us. So here, please understand this terminology, sir. When you write this terminology one should understand. So here we write, Fn is big omega of Gn. So actually what we need to prove, C times Gn is less than or equal to Fn. If you write it, all these terminologies automatically follows. What does it mean, my dear friends? Fn grows at least as fast as Gn. At least means minimum that or more than that. Fn grows at least as fast as Gn. Am I clear? So that is the idea, my dear friends. Correct? Now here we can say that for Fn, this Gn becomes asymptotic lower bound. For this Fn, Gn becomes asymptotic lower bound. See, it is not for small values of N. See, if you see for small values of N, the situation is not under control. But after this N naught, always C times Gn is dominated by Fn. Always C times Gn is dominated by Fn. Is the idea clear? Yes or no? Got it? Actually, when you say Fn is big omega of Gn, what do you mean by that? C times Gn is less than or equal to Fn. But when you say Fn belongs to big omega of Gn, what does it mean? We are not just talking about one particular function, sir. See here, when you say this function belongs to this class. But big omega of Gn is not just one function, sir. One function equal to big omega of Gn means it's not like Fn is this. Fn and this are equal. See, even though you write this for brevity, but this is what we need to understand here. In this class of functions, this function belongs to. Or this is a class of functions which contain all such functions. Am I clear? So that is the meaning of that. So when you say big omega of Gn, it's not just one function, sir. Collection of all functions satisfying this condition for large values of N. So that is the definition of big omega, my dear friends. Am I clear? Now, when you say big omega of N square, there are so many functions which belongs to this class. All these functions. There are some examples. These are not, complete list, my dear friends. These are some collection of functions which belongs to this particular class. All these functions. You can give so many functions like this. Now you see all these functions are having N square as their asymptotic lower bound. All these functions are having N square as their asymptotic lower bound. So N square is chota bai. For all these functions you can call N square is the asymptotic lower bound. Am I clear? समझ में आया है? Got it? Now let us see the theta notation. Big theta notation. Let us try to understand with example, then we write the definition. What do you mean by Fn is big theta of Gn? See, when you say Fn is big theta of Gn, the meaning of this is Fn and Gn are having equal order of growth. Here it is not like Fn is equal to Gn, sir. No. Fn and Gn are having equal order of growth. So what does it mean actually? What do you mean by proving that Fn and Gn are having equal order of growth? For this, we need to find two constants, C1, C2 and of course N naught. How, sir? Such that some constant times Gn is less than or equal to Fn is less than or equal to some constant times Gn. That is, this constant is C1, that constant is C2. Am I clear? Like that. So this is what we need to prove. When this should happen for large values of N. This should happen for large values of N. Am I clear? Now if you observe this, the left hand side tells you that Gn is asymptotic lower bound. And if you see the right hand side, what it will tell you? Gn is asymptotic upper bound also. So here it tells you Gn is asymptotic lower bound. And here if you observe, it tells you that Gn is asymptotic upper bond. So when it is both asymptotic lower bond and upper bond, so when it becomes both lower as well as upper bond, it becomes the tight bond. Therefore, we say that GN is asymptotic tight bond. Hope you understand. We call it as asymptotic tight bond. Okay, so it bonds Fn from both sides asymptotically. See here, the terminology you need to understand properly. Here we use the scripted notations. Okay, scripted notations. So here we say that Fn is asymptotically smaller than Gn, or we say that Fn is asymptotically larger than Gn. If it is asymptotically smaller or as well as larger, then we can say that Fn is asymptotically equal to Gn. Okay, so that is the idea, my dear friends. Now let me explain this with some example. Of course, these examples we need to find C1, C2, means we need to fix C1, C2 values. Accordingly, we need to find the values of N0, sir. But I'll give you a beautiful limiting formula with which we can verify whether the given function is big theta of another function or not very quickly. First, let us see this general methodology, then we'll go for the limiting method. Because that limit method also helps you in understanding small o and small omega notations. Am I clear? So let us see this. What do you mean by n square by 2 minus n by 2 is big theta of n square? What do you mean by this? N square minus 2 minus n by 2 is big theta of n square. So how you solve this problem, sir? We have to find C1, C2 and N0. We have to find C1, C2 and N0 such that C1 times n square less than or equal to n square by 2 minus n by 2 less than or equal to C2 times n square. Is the idea clear? Is the idea clear? Okay. Now, what values of C1 and C2 you have to take? So that this condition is true for all n greater than or equal to n0. What must be the values of C1 and C2? See, generally when you see this, what is the highest order term? N square by 2. So coefficient is 1 by 2, no? So you can take C1 as anything less than 1 by 2. Anything less than 1 by 2. So let us take 1 by 4. And it should be positive constant also. And here C2, it should be anything greater than 1 by 2. So because we generally like integers, here it is not possible, therefore I taken 1 by 4. But here it is possible, no? So I take C2 is equal to 1. See, if you want, you can take 3 by 4 also, there is nothing wrong. 1 C and 1 N0 you have to find. See, we don't have to prove it for every C and every N0, sir. We don't have to prove it for every C and every N0. 1 C and 1 N0. Okay, so let me put that. 1 by 4 n square is less than or equal to n square by 2 minus n by 2 less than or equal to n square. See, if you observe, the left hand side problem is same as your big omega problem. The right hand side problem is same as your big O notation problem. That's it. Okay. So you can find the values of n1 and n2 in that manner, my dear friends. Therefore, here it is 1 by 4 n square, that is n square by 4 less than or equal to n square by 2 minus n by 2 less than or equal to n square. So if you solve the left hand side part, what happens? I take n square by 4 to the other side. It is n square by 2 minus n square by 4 is n square by 4 minus n by 2 greater than or equal to 0. And if you take the right hand side part, here you take n square by 2 to the other side, therefore it is n square minus n square by 2, which is n square by 2 plus n by 2, which should be greater than or equal to 0. Actually here it satisfies for all n greater than or equal to 0, but here if you take LCM, 4 is the LCM, n square minus 2n greater than or equal to 0. That means taking n common, it is n into n minus 2 greater than or equal to 0, because n must be positive constant, this cannot be 0. Product is positive means both must be positive. Because n is positive, n minus 2 must be greater than or equal to 0, therefore n greater than or equal to 2, my dear friends. Is the idea clear? समझ में आया है? So, both the condition must be satisfied. This condition must be satisfied, this condition also must be satisfied. When both the conditions are satisfied, my dear friends, both the conditions are satisfied, both the conditions are satisfied when n is greater than or equal to 2. Because here 0 is this and 2 is here. I want something which is satisfied for both the conditions. One condition say it should be greater than 0, one condition say it should be greater than 2. When both the conditions are satisfied. When n is greater than 2, both the greater than or equal to 2, both the conditions are satisfied. So what is your n naught, sir? N naught is equal to 2. Is the idea clear? All of you able to follow? The big theta notation is clear. This is how we need to verify whether a given function is big theta of another function or not. Okay? Now, okay, I want to solve this problem. Now I am going to give you the shortcut method for this. Am I clear? You don't have to do this entire story, my dear friends. Using limiting approach, you can verify this. Okay? This limit formula we generally learn under calculus. Okay? If you attend my calculus classes, I will be explaining this calculus formula in more detailed manner, but here I will tell you in a nutshell. Okay? So let us see this. I want to prove this 2n square plus 5n is equal to big theta of n square. For example, whenever you want to prove that fn is big theta of gn, remember this, the limit formula. What you do is you take limit, because we want it for large values of n approaching infinity, fn by gn. See, whenever fn and gn are having same order, this limit will tend to a constant which is not equal to 0. If this limit tend to a constant which is not equal to 0, that means they are of same order of growth. In that case, you can happily say that fn is big theta of gn, my dear friends. You can use limit formula and you can happily solve this problem. See, under this learn with video lessons part, okay, this algorithm course was done by me, and these problems, I solved many such problems, my dear friends. And some of the videos you can freely watch. So you can go through those problems. This asymptotic notation and order of growth, I created almost 6 to 7 videos on that. All the limit formulas and limit problems I discussed under that. So I want you to go through that for clear understanding. Here also I am giving you the idea in a nutshell, but there I discuss many variants of that. Am I clear? Like this. So now this problem, you want to prove this fn is big theta of gn. So what I am doing is, I take fn is what? 2n square plus 5n. What is gn? n square. So take limit as n approaching infinity, 2n square plus 5n divided by n square. Now please remember this small trick which I am going to tell you. Whenever numerator is a polynomial and denominator is also a polynomial of same degree, numerator and denominators are of same degree, polynomials of same degree, and limit n approaching infinity, the answer for this is coefficient of highest power term in the numerator by coefficient of highest power term in the denominator. What is coefficient of this one? Don't write 0, sir. Some people take 0 there. Don't take it. So what is the limit, sir? Limit is 2, which is non-zero finite quantity. Therefore, I can clearly say that 2n square plus 5n is big theta of n square. See, if you want, you can use C1, C2 constant method. That also you can try, sir. But I given a shortcut method. Am I clear? For this, I just given shortcut method. If you want, you can try this. C1 n square less than or equal to 2n square plus 5n less than or equal to C2 n square. This method also you can try. Am I clear? Hope you understand. Try this as homework. Now the definition for big theta notation. So we say that fn is big theta of gn. What is the meaning of that, sir? We need to find positive constants. All must be positive constants. C1, C2 and n0. How? Such that this condition is satisfied. When this condition must be satisfied, sir? This condition must be satisfied for large values of n. So we could able to find a value of n after which this condition must be satisfied. Am I clear? Like this. So this is fn, this is C2 gn and this is C1 gn. And if you observe, this is the point n0. Before this point, the situation may be not under your control. But after n naught, this condition is always satisfied. What condition? C1 times Gn is less than or equal to Fn is less than or equal to C2 times Gn. Therefore, we say that Fn is big theta of G. Is the idea clear? Clear to you all? So, what do you mean by this, sir? Fn is big theta of Gn. When you say Fn is big theta of Gn, what does it mean? Fn grows with the same order as Gn. Okay? Or we say that Gn is asymptotic tight bond for Fn. Am I clear? So, this is the story, my dear friends. Tight bond. See, Fn is sandwiched between C1Gn and C2Gn. Fn is between C1Gn and C2Gn. That is the idea. Hope you understand. Clear? Right. And when you say theta of Gn, it is not just one function, sir. It is class of all such functions which satisfy this condition. Any function satisfying this condition is under this class of theta of Gn. See, strictly speaking, we should write Fn belongs to theta of Gn, but we write Fn is equal to theta of Gn. So sometimes people feel that theta of Gn means single function. It is not like that. See, for example, you see, this particular function is theta of n square. Not only this, you write 100n square plus 7n plus 6. Even this is theta of n square. Okay? How can you verify, sir? I given two methods. One is you can say C1n square less than or equal to 1000n square plus 1000n less than or equal to C2n square. This way you can prove it, or you can use limit approach. Limit approach. Am I clear? With both the methods, you can solve these problems. Same is the case for this. See, just take limit as n approaching infinity. 5n square plus 6n plus 9 divided by n square. The answer is 5 by 1, which is 5. Non-zero finite quantity, therefore this result satisfied. Am I clear? So this is about big O, big omega and big theta, my dear friends. Okay? See, for big O, what do you mean by big O, sir? We have to prove that Fn is less than or equal to constant times Gn. So we write like Fn is asymptotically smaller than Gn. When you say big omega, constant times Gn is less than or equal to Fn. Here Fn is asymptotically larger than Gn. What do you mean by big theta? In this case, some constant times Gn is less than or equal to Fn is less than or equal to some constant times Gn. This means Fn has equal order of growth as Gn. That is, it grows as fast as Gn, not more than that. Am I clear? Now what about this problem? Can you solve this problem using limiting approach? Just take limit as n approaching infinity, 3 into 2 power n plus 5n square divided by 2 power n. Apply limit. Now here, if you see this, 3 2 power n by 2 power n cancels, so that is 3, and the other part I am separating it. See, this limit can be separated if both the limits exist. You cannot blindly separate every time, sir. When both the limits exist, okay, suppose you are applying limit a plus b, a exists, limit a exists, limit b exists, then you can separately write it as limit a plus limit b. Otherwise, you cannot do it, sir. Please remember that. Okay, so this can be written as 5n square by 2 power n. Now this is a limiting formula. We get infinite by infinite, which is okay, indeterminate form. So we use L'Hopital's rule. Okay, here this is constant, sir. This will be waiting for the other fellow. Okay, once this activity is completed, this activity means this 3 can be added to that. So infinity by infinity means indeterminate form. We can use L'Hopital's rule or L'Hospital's rule, how you read generally. Am I clear? So applying L'Hospital's rule, differentiate numerator separately with respect to n and differentiate denominator separately with respect to n. What is derivative of n square, sir? 2n. So you get 10n, and denominator derivative is 2 power n log 2. You all know a power x, generally you write in that way, no? A power x derivative is what? A power x log a. Same thing, log 2. Again you get indeterminate form. Again you apply L'Hospital's rule. You get limit as n approaching infinity, 10 divided by, again 2 power n log 2 square. Whatever it is, As an approaching infinity, denominator is very large, so it tends to 0. You get 3 plus 0, which is 3. Because it is a non-zero finite quantity, therefore what happens, sir? We can say that this function is big theta of 2 power n. That's it. Hope you understand. Hi sir, good evening. A.B. de Villiers, very good evening sir. Am I clear? So this is about big theta, my dear friends. Okay? And for this problem, if you use C1, C2, that way also you can solve it, sir. So C1 you may have to take 2 and C2 you may have to take 3. 3 means 4, 5 or any big letter or big number, you can take it. And you can try that, sir. A power x log a. Wonderful, wonderful. 3. Good. Yeah, you are giving answer. Wonderful, sir. Now comes small o notation. So generally people confuse with this definition. So I am giving you definition in a very, very simple sense. Please see this definition. Because verification using the method which we use for big O, big omega and big theta is not that easy for small o and small omega. So I give you the limit formula for that. Am I clear? So let us see that. Yeah. See what you mean by Fn is small o of Gn. Fn is strictly bounded above by Gn asymptotically. That is asymptotically bounded above by Gn. See, you see, there is a less than, not less than or equal to. Fn is less than C times Gn. And here the important point to be noted is not only this, for every C, see when it is big O, for one C we have to find one N naught. But here we have to find N naught which works for every C. So it is strictly dominating it. That is Gn strictly dominating Fn. See, normally when you say big O means it may be equal or greater than that. Gn may be, that is C times Gn may be equal or greater than that. But here it is strictly greater than. Whatever C you take it, C times Gn must be larger than Fn. That is the condition. Good evening, Sagar Patil. Very good evening, sir. Very good evening, sir. So, this is very important. People misunderstand this definition. Please take this carefully. For every C, you have to prove this condition. It's not one C. Okay? So, Gn dominates Fn here. Strictly dominates Fn. Am I clear? So, you see this graph. Now, this is Fn. You take C times Gn. So, C times Gn. Of course, C times Gn may be like this also, sir. But whatever C you take it, definitely what happens, sir, whatever C you take it, any C, for every C, it is not for a single C, for every C we have to prove it. So you have to prove for C is equal to 0.1, 0.2, 0.3, or if you take only integer value 1, 2, 3, 4, for every C we have to find corresponding N naught. See, big O, big omega and big theta are very simple. One C, one N naught, done. But here it has to be true for, equality is removed. Not only that, it has to be true for every C. It is true for every C. Not for a single C. That is very important, sir. That point is very important. Am I clear? So that is actually the difference between big O and small o notation. It has to be true for every C. Big O means at least one C. One C if you can able to find, for which if you can able to find one N naught such that Fn is less than or equal to C times Gn. For every N greater than or equal to N naught, that is done. Therefore we can say that Fn grows no faster than Gn. Fn grows no faster than Gn, we can say. Means it may be having smaller or equal order of growth as Gn. But here Fn has smaller order of growth as Gn. How we will find? See, finding for every C is difficult. That's why we use limiting case, my dear friends. Am I clear? For that also there is a methodology, but we are not getting into that. See, we use a generalized procedure for that. And that procedure I am going to explain for you now. So actually, when you say small o of Gn, it is collection of all functions satisfying this condition, my dear friends. And how to prove that Fn is small o of Gn? How to prove that Fn is small o of Gn? What you do is you take limit, my dear friend. Limit as an approaching infinity, Fn by Gn you take it. Fn by Gn you take it. See here, which one is smaller, Fn or Gn? Which one is smaller, Fn or Gn? Which one is smaller, Fn or Gn? Fn has smaller order of growth. Okay, therefore this limit will tend to infinity, my dear friends. Because the lower, the denominator function is having higher order. So, because this is having higher order, for large values of n, this will dominate and the answer will tend to infinity, my dear friends. So, this method we use for verifying Fn is small O of Gn. Actually, we can use some mathematical induction method for verifying for every C it satisfies, my dear friends, but that is unnecessary for us. For computer science people, you just use this methodology, it is enough. Am I clear? Please remember one thing. When Fn is small O of Gn, then you can say that Fn is big O of Gn. See, what do you mean by small O of Gn, sir? Fn is asymptotically smaller than Gn. See, whenever it is asymptotically smaller than Gn, we can say that smaller or equal, there is nothing wrong. But reverse you cannot say. If you know that it is big O of Gn, we cannot say it is small O of Gn. But if you know it is small O of Gn, we can say it is big O of Gn, my dear friends. Hope you understand. Is the idea clear? Of course, Gn is upper bound for Fn, that is not asymptotically tight. That is how we say that. So let us say, take this particular problem, sir, 2n square plus 5n is big O of n cube. How you prove it? Just take limit. Limit as n approaching infinity, 2n square plus 5n divided by n cube. See, if you want, you can use L'Hospital rule or use this simple trick, sir. If numerator and denominator both are polynomials, if the order of denominator is larger, okay, I think it should be, sorry, I think I said infinity, I said. Sorry, when denominator, oh sorry, I am very, very sorry, I said, oh. I am sorry, sir. Very sorry. Reverse not true, sir. Okay, this is 0, sir. Because denominator is dominating now. When denominator is dominating, see, when you have 1 by n, as n approaching infinity, what happens? It gets 0. So it should be 0, sir. Okay, sorry for that. I have overseen that. So here, as n approaching infinity, this tends to 0. When the denominator power is more, the limit tends to 0. In this case, we say that Fn is small O of Gn. What reverse? C is equal to 1. For which one you want to prove C is equal to 1? AB de Villiers? Dear AB? For which one you want to prove C is equal to 1? See, you can try this for different values of C, my dear friend. Any positive real constants will satisfy this. That is 2n square plus 5n less than some constant times n cube. See, depending on constant, the n value changes. See, for every C, same n naught is not there. That is a misunderstanding. For every C, same n naught. No. For every C, we can find n naught. For everyone, there is someone. For everyone, there is someone. Hope you understand. See, for C is equal to 1, what happened? If you put C is equal to 1, what should be the value of n? For n is equal to 1, it is not satisfied. No problem. For n is equal to 100, you put and check. For n is equal to 100, you put and check. 100 means 100 square. Okay. 10,000, 20,000. Okay. Then plus 5 into 100, 500. So it is 20,500. And here it is 1000 cube. 1000 cube means, oh, it's not working. Don't worry, let us try this way. Let us take n is equal to 10 power. See, obviously this is smaller only, now what I am doing, sir? It is satisfied, no? 20,500 is smaller than this one. 10 n cube, na? Cube. So 0, 0, 1 more 0. Yeah, it is satisfied. See, depending on C, n naught may be at a far distance. For some values of C, n naught may be at smaller, earlier position. That's it. See, it's not like for every C, same n naught should work. No, that is misunderstanding. For every C, we can find some n naught. For every C, we can find n naught. That is the idea, my dear friends. So this is the result, my dear friends. When you say Fn is small O of Gn, we say that it is same like A is smaller. But here we should understand that it is asymptotically smaller than Gn. That is the idea. So now look at this problem. Fn is equal to 5n square plus 6n plus 9. Gn is equal to 20n cube. So how you solve it, sir? Same story. Take limit as n approaching infinity. 5n square plus 6n plus 9 divided by 20n cube. So as n approaching infinity, this tends to 0. Therefore, we can say that this function 5n square plus 6n plus 9 is small o of 20n cube. Is that clear? Sorry for that. Hope you understand. Good, sir. Good way. Good, AB. Very good. Now, what about small omega notation? Okay. What about small omega notation? Fn is small omega of Gn. What do you mean by that? For every C, we can find a small n naught. Not small n naught, we can find a n naught. We can find a n naught such that C times Gn is asymptotically, that is, C times Gn is smaller than Fn, or Gn is asymptotically. Gn is asymptotically smaller than Fn. And here how you prove this, sir? So here what is happening, sir? You see C times Gn is always smaller than Fn. Whatever C you take it. After a particular, see for example, you just multiply the C is say 2. It is here. Say suppose you make C is equal to 20, this graph may go like this, something like that. But definitely this will be a naught for that. For every C we can find a naught. For every C we can find a naught. That is the idea. For every C we can find a naught. Am I clear? So that is the idea. So Fn has larger order of growth than G. And when you say omega of Gn, it is not just one function, sir. All such functions satisfying this condition falls under or will be in this particular class, my dear friends. We actually need to say that Fn belongs to small omega of Gn, but we write Fn is equal to small omega of Gn. Because of that, some people have misunderstanding. Okay, but here we need to understand Fn is belonging to small omega of Gn, strictly speaking. But here we don't try to be so strict, my dear friends. Am I clear? That strict mathematicians are trying to be little strict, but here we simply use a lenient notation like Fn is equal to small omega of Gn. It's a lenient notation, my dear friend, but strictly speaking, this is how we should write. Am I clear? Yeah. Let me take one example for this. Same story. Here what should happen, sir? For this what should happen? For this what should happen? Take limit as n approaching infinity, Fn and Gn. Which one is larger? Numerator or denominator? When you say Fn is small omega of Gn, Fn is bounded below by Gn. So Fn is having larger order of growth than Gn. Therefore, this should tend to infinity. Because numerator is larger, this should tend to infinity. Am I clear? So simply if you want to solve this, just take limit as n approaching infinity, numerator divided by, this is a function no n. So as n approaching infinity, because both are polynomials, numerator is having highest order, this limit will tend to infinity, my dear friends. This limit will tend to infinity. Okay, so we say that this condition is satisfied. So please try to understand. In a nutshell, I just revise all the notations once again, my dear friends. So see this carefully. If you say that Fn is big O of Gn, we actually denote in a simple sense like this. That is a scripted less than or equal to, my dear friends. Here we say that Fn is asymptotically smaller or equal to Gn. When you say Fn is big omega of Gn, what does it mean? Fn is asymptotically larger or equal to Gn. And when you say Fn is big theta of Gn, what does it mean? Fn is, see here, we use this equality notation. Fn is having equal order of growth as Gn. Am I clear? And when you say Fn is small o of Gn, what does it mean, sir? It means that Fn is asymptotically smaller, not equal. And when you say Fn is small omega of Gn, what does it mean, sir? Fn is asymptotically larger than So this is the story, my dear friends. Am I clear? So this is about the asymptotic notations. Most of the time we use this big O notation because it is a safer notation, because we can say that this function is smaller than some function. It is having same order of growth. This is generally little difficult to prove. Of course, maybe for some limit problems, if limit is finite value, that can be done, but sometimes that limit may not exist. There are some problems where the limit does not exist, but they have the same order of growth. Am I clear? So that type of problems also will be having. Am I clear? So these conditions, whatever I given, the limit conditions are sufficient but not necessary. They are sufficient conditions but not necessary, my dear friends. If you are lucky, the limit condition is satisfied, that is limit is equal to finite not equal to 0, Fn is big theta of Gn. If it is equal to 0, Fn is small omega of Gn. If it is equal to infinity, means tends to infinity we should say, then we say that Fn is small o of Gn. Am I clear? So that is the idea, my dear friends. So with this I conclude asymptotic notation. From tomorrow I am going to start time complexity. I am going to solve time complexity problem, time complexity 1, time complexity 2 and time complexity 3. Next 3 days I will be discussing this. Next 3 days, that is today is 21, right? So 22nd, 23rd and 24th I will be discussing this. And in the app I will be taking free app classes. These classes are at 8 p.m. my dear friends. Tomorrow, day after tomorrow and on Friday. Again, Saturday, Sunday we don't have classes, but 25th and 26th I will be taking classes on solving recurrence relations. Solving recurrence relations. See, I already done a topic on recurrence relations, sir. Okay, how to think recursively. I done one topic earlier. After seeing that, you can see these two topics, because there I only discuss recurrence relations, how to create recurrence relation, how to formulate recurrence relation. Okay, the idea of recursions I discussed, but on 25th and 26th we learn how to solve recurrence relations. Same story, 8 p.m. my dear friends. And on the app, tomorrow and day after tomorrow, 4 p.m. I will be discussing indexing formula. So indexing formula is actually a general formula based on arrays, my dear friends. So you all know in C programming how the array indices are used, but here we will be talking in a more general sense, not restricted to C language. So that I will be discussing on tomorrow and day after tomorrow, that is 22nd and 23rd on app, my dear friends. BYJU'S Exam Prep app, I will be discussing this. Okay. So that's all for today, my dear friends. Of course, the same story. You can try these problems. That's all for today, my dear friends. If you have any doubts, you can ask me. Otherwise, I'll call it a day. Now the time for doubts. You can ask me doubts if you have any. So I'll be starting with this time complexity from very basics, my dear friends. Okay, we'll learn how to find time complexity of simple codes. Okay, then we try to go for nested loops and nested independent loops, nested dependent loops. All this we try to discuss in a detailed manner in the next 3 classes. The time complexity concept will be discussed in a more detailed manner, of course, mathematically also. Am I clear? So that I'll be doing next 2 classes. Am I clear? So that's all for today. If you are having any doubts, please ask me, sir. Hope no doubts. Then thank you.